Hey guys, welcome to your first video recorded lesson for Unit 1, Quadratic Functions. In the first assignment, you were shown a bunch of videos about the basics of quadratic functions. And you saw what you're seeing right here in this box is the standard form for a parabola, right? The shape of this graph, or what we call a quadratic function. So in what you're seeing now is the most fundamental, the most basic form of a quadratic function. This is what happens when a is 1, b is 0, and c is 0. So let's first think about what happens when you use zeros in an equation. If b is 0 up top here, anything times 0 becomes 0, right? So that b of x cancels out. C is also going to be 0, so that's going to not affect our equation as well. That's going to go away. And all we're going to be left with is y equals ax squared, right? So we're eliminating the options of having a b or a c and only talking about a. So let's take a look at what happens when you change a. I'll open up a separate graph here. So what I have showing on the screen is the purple graph is your basic x squared when a is 1, right? We don't need to show that 1, right? Let's see what happens when I put a 1 in front of x squared. Notice how it doesn't change at all, right? So that 1 isn't affecting the shape of the graph. But if I make a bigger than 1, let's say I make it 2, right? This red graph that was underneath the purple at first now became thinner. And we see how now I can kind of move this slider, take this away. If I make it, the bigger I make A, the thinner this graph becomes. And that was what we wanted you guys to notice in the first lesson, right? What happens when you're changing A? So when we change A, the graph becomes thinner than x squared, which is what we call the parent function. It's the most basic, the most fundamental. Every other quadratic function comes from x squared. Changing A makes you thinner when your a becomes larger than 1. Well, what happens when your a gets closer to 0? So let's move the slider. Now I'm looking at decimals that are between 0 and 1. And notice how the red graph is becoming wider and wider until eventually we hit 0 and it flattens out. So if I'm using an a value that's between 0 and 1, my graph is going to become wider than x squared. So you're always thinking about how the graph is changing based on the parent function. Okay, so now we're at 0, and our graph is flat. It's no longer quadratic. It's just a flat line. Let's bring it back. What happens when my a value becomes negative? So let's check. I'm going to go back. All of a sudden, the graph is flipped. It's opening downward this time. X squared starts by opening up. And now when our a value is negative, or that number in front of x squared becomes negative, now we're opening down. It's a change in what we call concavity, right? So now, before we were concave up, now we're concave down. So let's check out a few of these conditions. I'm at -1, right? So this is the opposite of what we see in the purple. In the purple graph, which is x squared, our a value is +1. In the red graph, our a value is -1. It's the opposite. So we see the x squared graph fully flipped. Let's see what happens when we get more negative. You might be able to make a guess now, right? Predict what's going to happen. Well, it's going to start getting thinner, right? The more negative I get, the thinner this graph gets, right? Because what's really happening is that the values, as we're plugging in x values, the values are decreasing or increasing at a faster rate. So it's instead of taking its time to go up or to go down, it's going really fast, up or down. And lastly, we're going to look at what happens when our a value is between 0 and -1. So let's change our slider here, getting closer to 0 again. And notice, once again, we're getting wider than x squared. So the closer I get to 0, the wider my graph gets on either side, positive or negative. The further away I get from 0, the thinner my graph gets. And this is a way that you can make predictions about how a graph is going to look by understanding what each piece of the function does to its graph. So in the next lesson, we're going to talk about what happens when we add a c value. How is the graph going to change?